In this podcast, we're going to talk about what a cycloalkane is, and we're also going to discuss how to name cycloalkanes. So just as you would imagine, a cycloalkane is an alkane that has a cyclic or a ring structure. So cyclo just tells us that we have some sort of ring structure. Your carbons are connecting into a circle of some sort. The beginning becomes the end. The general molecular formula for this is CnH2n, and that's not something you need to memorize. I just want to point out what that formula means really quick. So let's start with the number of carbons we have, say, in this cyclic structure. We have 1, 2, 3, 4. So this would be C4. And to determine how many H's we need, we would say 2 times N or 2 times 4, which is 8. Let's go double check that that worked out. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Now, as we have said before, we don't typically show a cyclic structure in a complete structural formula. We also don't show these in condensed structural formulas. Oftentimes we use skeletal formula for cyclics. So let's go ahead and simplify this. And remember, we just draw lines between carbons and connecting our carbons. So a cyclic structure for this cycloalkane would look like a square, where each of the points, each of the lines that come together, that represents a carbon, and we assume that there are hydrogens completing octets all the way around. All right, let's talk about naming, and let's also take a look at these structures. So usually when we're doing cyclic alkanes, these tend to look like geometric figures. We have a triangle and a square and a pentagon and a hexagon. So these are geometric shapes, and they represent a structure that has 3 carbons in its ring, 4 carbons, 5 carbons, and 6 carbons. So we'll practice our naming with these structures since they're basic at first, and then we'll move on to some more complicated examples. So what you need to do first is you need to figure out what the parent chain's name is. So here we have 1, 2, 3 carbons. 3 is prop, and these are alkanes, so I'm going to end it with ane. So this is propane. So all we're doing is putting the word cyclo in front of propane, and that tells us, and that should be one word, I just didn't plan the word well. Cyclopropane tells us that this is not a straight chain of propane. This is a propane that connects the last carbon and the first carbon together. In this next one, we have 4 points, 1, 2, 3, 4. So our prefix is bute or bud. And it is all single bonds, so ane, it's an alkane. And it's cyclic, so we just put the word cyclobutane in front of it, and this is cyclobutane. 5 carbons, each of these, where these lines come together, is a carbon. 5 is pent, all single bonds, so we end this with ane. Because the first carbon connects to the last carbon in a cyclic structure, we need to tell our reader that this is cyclic, so we call it cyclopentane, because pentane by itself is just a straight chain. And finally, this is hexane. It has 6 single bonded carbons, but it's cyclic. Whoop. So it's cyclohexane. In the next slides, we're going to see where it gets a little bit more complex. So if you have a branch present and if there's only one branch, there's no need to number the carbons in the circle. You just assume that this branch automatically gets position number 1. However, if there are 2 or more branches, they have to be numbered because you have to tell me how close or how far apart or what carbons these branches are on. So we're going to give lowest number an alphabetical preference in our name, and we're going to practice that so you know what I mean in just a moment. All right, so we have 4 examples to do because these can be kind of tricky, and I tried to pick some different situations where we could see some different things happen in here for your reference later. If at any point you're feeling confident, you're feeling comfortable, pause this, do them on your own, check in with me, see if you got them right. If not, figure out what you did wrong. All right, so let's start with this top structure. We have a cyclic structure, and I always like to count because sometimes our eyes can deceive us. So we have 1, 2, 3, 4, 5, 6. There are 6 carbons in my parent chain. all single bonds, so this is hexane. Ooh, but it's cyclic, so make sure it's cyclohexane. However, I do have a branch. It is a single carbon branch, so we use the prefix meth with a YL to tell us it's an alkyl branch. So we have a methyl group coming off of our cyclohexane. So we need to be sure to designate that. Methyl cyclohexane. This can all be one word. We don't use dashes, we don't use commas here. As our instructions tell us, if there's only one branch, there's no need to number it. It automatically gets carbon number 1. It gets the 1 position. If you were to accidentally do this on an assessment early on, I'm not going to mark you off because it's not wrong. It's just unnecessary to write that. Usually we number when we ask ourselves, could this branch be anywhere else? In this case, it cannot. No matter where I put it on there, it's still 1 because I get to choose where to start my numbering. This next example, we have 1, 2, 3, 4, 5. So we have 5 in our parent chain. That is pentane. And it is a cyclic structure, so I need to call this cyclopentane. So that takes care of my parent ring structure. I have 1 branch coming off, so that tells me that I don't have to number this. But I do need to count how many carbons are in my branch. I see 1, 2, 3, 4 carbons. As a branch, this is an alkyl group branch. So I'm going to use the prefix but, and I add YL to that, just like I did with meth YL, methyl. But YL, or butyl, tells me that I have a 4 carbon branch coming off, alkyl branch. So this is butyl cyclopentane, all one word. If I were to put the 1 coming off of it, again, it's not wrong, it's just unnecessary. You don't have to put that. I always tell students, when in doubt, number it, because it's not wrong, but it is wrong if you accidentally forget to number it and it was supposed to be numbered. All right, our next example, we have 1, 2, 3, 4, 5, 6. Okay, you know what? I'm going to skip this and save that for the end. Let's go here. 1, 2, 3, 4, 5, 6. So the parent chain is hexane, and it's cyclic, so I'm going to put cyclo. And we have 2 1-carbon branches, alkyl branches. We have 2 methyls on here. Okay, so never do chemists like to be redundant. We wouldn't say methyl, methyl. Instead, we use the prefix di-methyl to say that we have 2 methyl groups. What's very important, we're now at naming example number 3. We have 2 or more branches present, so we have to number these guys. So I could start numbering here 1, 2 to give that order, or I can count going in the opposite direction, 1, 2. In either case, you have the same group. So in this case, it doesn't matter which one gets a 1 or which gets a 2 because they're both methyl. But it is important in your name to say 1, 2. Give me the carbon number for both branches. 1, 2, dimethyl cyclohexane. All right, skipping back up, let's look at this example. All right, so we have a 6-carbon parent chain. So I'm going to call this hexane. It's cyclic, so we need to call it cyclohexane. Now we have a methyl group, and we also have a 2-carbon or an ethyl group. So now, even though we could count this 1, 2, we could also count the other way, 1, 2. Now it actually matters which direction we count, because no matter what, the numbers don't change. It's either 1, 2 or 1, 2. Okay, now I have to give precedence to whichever group comes first alphabetically, and they're going to come first in the name as well. So ethyl comes first, so I'm going to use the purple numbering scheme for this. So ethyl also needs to come first in the name. So this is 1 ethyl, 2 methyl. And remember that we separate letters and numbers with dashes, and we separate numbers and numbers with commas. So this one is a little bit tricky. That's the most complex we're going to get for a little while, but this is 1-ethyl 2-methyl cyclohexane.